Welcome to our second live stream of All Things Automotive. If you're curious to learn what AWS is doing in the automotive industry, you've come to the right place.
This is a show where we dive deep into the auto tech news, look at emerging technologies, talk with our AWS customers and our own specialists on some of the most important issues in the automotive industry.
We have an exciting season with at least 8 shows, all focused around edge to cloud, with a focus today on the network edge and our partnership with Verizon.
Deploying software in vehicles and have those vehicles in a huge big network. Love that. Ready to start engines, Dean?
That's right, Stefano, let's roll. Welcome, everyone. I'm Dean, Worldwide Tech Lead for Automotive at AWS.
Hi, I'm Stefano. I'm Principal Specialist Solutions Architect in AWS.
And I'm based in the Motor City, Detroit, Michigan. How perfect is that for all things automotive? I've always had a passion for things that move, things with engines, whether they're cars, trucks, or planes, boats, or motorcycles, you name it. And when you combine that with the technology of today, I can't think of a better industry to be in at this time, or a better co-host to do the show with. So, Stefano, take it away.
Thanks, Dean. It's awesome to be here with you. So, I'm from the Italian Motor Valley, land of good food and powerful engines, But loving computers as well, now I'm in the Silicon Valley in California to try to get best between cars and computers. And as the perfect and most ambitious combination of the two, right now I'm very much focused on autonomous vehicle technologies.
Well, we're excited for what we've got planned for the show. We've organized at least 8 episodes all around the theme of edge to cloud and back. And here's a member of our All Things Automotive team, Julia McAndrew, to tell you about what's ahead.
In this week's leg of our journey from the edge to the cloud and back, we're making an important stop to explore the landscape of connected vehicles. For episode 2, our hosts Dean and Stefano will be diving into the C-V2X, or Cellular Vehicle to Everything, capabilities that make the driving experience safe up to fully autonomous levels, the feature-rich peaks of level 5. And since 5G and edge computing infrastructure are playing a key role in accelerating innovation, there's no better companion for this part of our trip than the team at Verizon. So buckle up as we adventure together into all things automotive and talk C-V2X and 5G MEC.
Well, after that, again, I'm ready to go on a road trip. What about you, Dean?
Absolutely. My bags are packed, Stefano. But before we bring on our guests, we'll always kick off each week with a little discussion about current events in the industry and some news that might be interesting. So why don't we get things going, Stefano? What's driving the news these days?
So yeah, Dean, you really are one of the industry leaders, right, in this sector when we talk about vehicle connectivity, DSRC, and the C-V2X. We immediately start with an early time warning here. So first of all, can you please explain what all these acronyms refer to, and then give us an idea about what's happening in the sector right now?
Yeah, well, really, it's all about what we call vehicle-to-vehicle communication. So it's about cars being able to send messages, broadcasts, like they do it like 10 times every second to say, hey, I'm going this direction, I'm going about this fast, and I'm in this location. And it helps cars understand what they can't see around the corner. And then it communicates with other roadside infrastructure like the traffic lights and things like that. So, when we say DSRC, we're talking about dedicated short-range communications, and this is basically a separate radio in the vehicle. And then when we talk about cellular vehicle to everything, C-V2X, we're talking about using the cellular modems in the vehicle to send those same kinds of messages.
Got it. Interesting. And so what about this that I read in the news, this white paper, right, that states that DSRC is running out of gas and the C-V2X is gaining ground. Is that what you see happening? And how do we see cars communicating in the futures?
Well, definitely, you nailed it. I think the point is that DSRC, being an older technology developed, years ago, 10 years ago or so, it's built on Wi-Fi signals. So what happened was the auto industry is always trying to, optimize. Why don't we build the same capabilities that we had for peer-to-peer communication and DSRC messages into the cellular specification? So the 5G AA got together, was formed to inform the telecom industry to develop the specification for 5G to allow these kinds of peer-to-peer messages, but using the same modem that's in the vehicle. And then we don't have to have the extra infrastructure costs added to the vehicle. And so the roadmap you see on the screen here kind of talks about how the different, how we start with kind of the basic safety messages, that the vehicles can understand, what's coming around the corner, for example. And then we're going to evolve into advanced capabilities to kind of support the autonomous and the ADAS systems. So getting into things like teleoperation and other advanced capabilities we'll talk about later on in the show.
So yeah, we can say that an ADAS and an autonomous vehicle has to be connected in a way or the other. But it's not just technology here, right? So regulations have a super big role. And on that, I read that in the US, the FCC approved a rule change in mid-November last year, right? That allows the previously closed vehicle to infrastructure V2X communication channel to be open for unlicensed Wi-Fi. And this will surely have tech operators more excited, right? In V2V, at least here in the US. And happy to have Verizon with us to talk about that later today in the show.
Absolutely. Yeah, we're looking forward to hear what Jody has to say to us about the capabilities of 5G MEC and what it will mean for advanced driving systems like autonomous and ADAS. But, as an example, kind of one of my recent contacts, I was talking with Chetan Merkley, who is CEO and co-founder of Locomation. He's actually going to be on a talk we're doing in a few weeks at the World Congress Experience with me around connectivity. But anyway, he was talking about how they're leveraging this technology and the MEC to enable platooning. So they're a long-haul trucking company. And what we mean by platooning, as you can see in the picture, is the vehicles behind the lead truck kind of connect and hand over control, if you will, so those drivers in the vehicles behind can actually rest. And then you gain the benefits of the fuel economy from the wind tunneling in the airflow. So it's really a cool concept. But that's one of them. And then, the other thing we talk about a lot with customers is around teleoperations and, what are the capabilities of, the MEC when it comes to enabling that. And that's kind of like, driving a vehicle like a drone, if you will. Lots of potential around that. We'll talk later again.
Yeah, very, very interesting. All these things, they relieve the drivers and the operators of many, many repetitive tasks. So I see a very, very, very useful case for them. So awesome. Yeah. It seems things are starting to move after several years of R&D, lab activities, and field tests. And another signal is acquisitions, right? So Harman acquired one of the most important startups in vehicle connectivity on the market, Savari. Yeah. Absolutely. And switching gear to another topic, Dean, vehicle connectivity is not just for safety, right? So now we have all kinds of data transfer happening for infotainment, car navigation, service, and remote diagnostic. And what are the most recent news there, Dean?
Yeah, well, we noticed that SAE shared a study from Umlaut where they were highlighting the close connection between connectivity and user experience. Obviously, when you think about the benefits of low latency and high bandwidth, we can bring totally new experiences into the vehicle, focused around infotainment or driver support or passenger information systems. So things like being able to check your Ring camera while you're, at home. I mean, while you're driving, or the passenger can check it, or maybe you're stopped if you're the driver. So we can bring in those video feeds. We can enable video conferencing. I mean, how many times have you been in the car where you needed to hop on that chime call, clearly not to watch while you're driving, but you want to be able to check into your web conference system while you're, and keep working while you're on the road. So things like that, different infotainment or entertainment options, rear seat entertainment. Based on that study and just stuff, conversations we had on our own talking to customers about the benefits of MEC and 5G, Clearly, we think obviously the first moves will be in the space of infotainment, and then perhaps moving into some of the more advanced use cases later.
Yeah, and talking about advanced use cases, we should not forget about our own Alexa and Fire TV. So it's becoming more and more common to have our voice assistant in cars. But we will see for the first time an Amazon Fire TV for auto in the 2022 Jeep Grand Wagoneer. Do you know about that, Dean? So
yeah, that's a
pretty
beautiful
cool
vehicle. Yeah,
Yeah.
I'm excited to see what happens with that. That's great to bring back an old standby, and I love to see how the OEMs are bringing back these different vehicles, the older ones from the past that had so much passion and following, and then think of a Jeep Grand Wagoneer equipped with Fire TV. It just kind of blows your mind. You think about it.
Absolutely. And it's if you think about that, it's a service that will not exist without adequate cellular connectivity. Absolutely. So much progress is in the last few years on that.
Yeah, absolutely. Well, as you know, you and I could talk for hours about automotive news, especially when drinking some of the fantastic wines of the Italian Motor Valley. I think
bet.
you were saying what Lambrusco is one of the big wines there. I'm partial to Italian, so I looking forward to any opportunity we can have to have some fun. But why don't we move on and talk to introduce our guests? Our first guest is Jody Sharma from Verizon. Jody, you and I first met back at CES in 2020. If you can believe that was just last year, but considering what's happened over the past year, it feels like eons ago. And we've done so much in the meantime together. So why don't you tell us a little about yourself?
Thanks, Dean and Stefano, for having me on your show. It's a pleasure to be here. And I lead tech strategy for automotive within Verizon. I'm based out of Basking Ridge, New Jersey. And I also represent Verizon within 5G. I've been in the wireless industry for a couple of generations of wireless. So I'm pretty excited to share my journey through this 2G to 3G to 5G now. But Dean, yeah, you're right, absolutely right. We met at CES 2020, and I'm glad I was able to visit you at the AWS booth where we were just conceptualizing some of these use cases. And we've come a long way in this journey with 10 metro cities having AWS Wavelength commercially deployed jointly between Verizon and AWS, and the work that we've done with the ISVs. So I'm really excited to share all that we've accomplished in the past 1 year or so. And both the teams, I want to take a moment to recognize how much work has gone behind and teamwork from both AWS and Verizon to make this a reality from concept.
Yeah, really interesting. And talking about generation, I'm wondering if you still call for dinner your 2G or 1G grandma, And anyway, our next guest is from AWS, our colleague Savi. There she is.
Thank you, Dean.
Hi, Savi.
Hi, everyone. Thank you, Dean and Stefano, for having me on this show.
Yeah,
Savi, you work in the AWS Wavelength team, right? And we had some awesome customers interaction together. You want to tell us more about yourself?
Sure. My name is Savi Venkatachalapati, and I'm based out of San Francisco Bay Area. And I'm the global go-to-market specialist for AWS Wavelength. And in this role, I have been working with some of the automotive customers, especially on the C-V2X use case trials with AWS Wavelength and Verizon. And super excited to be on this show and I'll talk a little bit about it.
Well, we're so glad both of you joined us today, and we're really looking forward to learning what you have to say about this, so very important topic to our industry. So now that we've done our introductions, let's get under the hood with Verizon and AWS Wavelength. So Jody, help us understand what's so different about this next generation of telecom. I mean, every time we advance a G, as we say, it's always been a significant transformation and it's going to solve everything. But it's always a big deal. But what about the move to 5G is so special and unique?
Yeah, Dean, great question. And I've been around, as I said, a few generations, so I can talk about how this generation of wireless technologies is different from the previous generation. As we move from 4G to 5G or 3G to 4G, there's always higher speed that's on everybody's mind, and we're looking at higher data rates, high throughputs. But 5G is much more than what just higher data rates. What 5G brings, according to the 3GPP standards, is 8 different currencies or capabilities, as we call them. It's not only providing high data rates, high throughput, high speeds, but at the same time, it's providing really ultra low latency, providing massive number of IoT devices that can be connected to the network. And this is all on the foundation of mobile network operators like Verizon laying that groundwork of laying the fiber, getting the relevant spectrum, whether it's in low band, mid band, or high band millimeter wave, having that great asset. And spectrum is really the real estate for wireless technology. So we are very happy. We recently acquired the C-band spectrum, as you all know. So that's going to be key, having the right spectrum. And then the software-defined radios is also going to be key in terms of deploying this technology. And I think one biggest technological enabler that we're going to talk about today is MEC, or mobile edge computing, which will augment 5G capabilities and provide that ultra low latency experience, local context, security, reliability to our automotive customers.
Yeah, so Jyoti, thanks for this really nice explanation. So, and Dean and I were talking about C-V2X and the role of telecom providers like Verizon in our introduction. So, do you think C-V2X will deploy at scale with Sidelink or through the MEC? Oh, yeah, just need a heartbreak here. So, let's get back one step behind. So, can you explain really in basic terms what Sidelink and MEC are and why are so important?
Yeah, sure, Stefano. I'll be happy to. So we've been looking at C-V2X for several years now. And as you know, in 3GPP standard release 14 introduced this concept of cellular vehicle to everything, where the vehicle can communicate with the other vehicles over V2V, with the network over V2N, with the infrastructure like the traffic lights over V2I, and with the pedestrians over V2P. So C-V2X is a technology that was rolled out in release 14. And with every release, we are adding new components and advanced features to it. As you can see on this slide, and I think Dean referred to it earlier, the older technology was called DSRC, or Direct Short Range Communication, or V2V communication. And this was planned to be deployed over the ITS spectrum, which is the 5.9 gigahertz band that you alluded to in your previous discussion. And with the recent FCC ruling that came last November, the FCC has reallocated that 5.9 gigahertz spectrum, with the top 45 megahertz being allocated to the Wi-Fi, unlicensed Wi-Fi, indoor to start with. And then the lower 30 megahertz of that spectrum has been allocated to C-V2X, or PC5 in the technical terms, in the standards as it's referred to. So there are 30 megahertz that are allocated for ITS band for safety applications for V2V communication. And people are leveraging that link. But there's also another link, which is network communication, which is 4G, 5G connectivity. And as you know, the future of a connected and autonomous vehicle, it's connected, it's autonomous, it's shared, it's electric. So we envision and we see most of the auto OEMs will provide connectivity, 4G, 5G connectivity in their upcoming vehicle models. That's going to be table stakes. Everybody's going to expect that. And we believe we can deliver several value-added services over that 5G network connectivity.
Yeah, that's fascinating, Jody. It's a great explanation of what this technology is all about. But as you know, in the past we've always defined the edge as the actual endpoint, like the vehicle. But now with the MEC, we really need to talk about the network edge. That's how we talk about it. So why don't you kind of go over some of the use cases that we see supported by the 5G MEC?
Yeah, sure. So as I represent Verizon within 5GA, both in Working Group 1 and MEC for auto working items and work groups. And we looked at almost 200 plus automotive use cases in cooperation with the automotive customers, auto OEMs, tier ones, and really categorized all those use cases in different buckets, so to speak, and then selected some of the high running use cases that will be leveraged over the coming years. And MEC or 5G Edge is a key technical enabler for some of these vehicular use cases, as we'll talk more about teleoperations, infotainment that you refer to, where people are looking for not RPM, but they are looking for experience per mile. And they are used to the same experience with their mobile devices and at home. And vehicle is that third space where they want that seamless experience in the vehicle. And 5G Edge or MEC will be able to provide us with this low latency and all that edge computing that's happening on the edge. And the vehicles are generating terabytes of data per hour. That data is offloaded quickly to the MEC where it's pre-processed, and then it's sent back to the cloud for post-processing, and then back to the vehicles with some intelligent decisions that can be made off the vehicle. So that helps us latency with 5G. We're going to be able to offload a lot of compute from the vehicles to the MEC. And by bringing the storage and compute closer to the edge, it's just going to enable several use cases that were previously not possible.
Wow, so really so powerful. Jyoti, I'm always very fascinated about laboratories and experimentation. And I'm wondering, how do you do your early research and experimentation in this space? Do you have location where you test this technology with real cars, with the Mac, with equipment? How do you do that?
Yes, absolutely, Stefano. We're testing with real cars on real tracks and almost real road conditions. For example, at M-City, we're part of the leadership circle at M-City, and we bring in our partners and our customers to the M-City location and do drive testing. And as you can imagine, before we bring any such technology on the real roads, it has to be thoroughly tested. And we need to make sure that our networks can meet the requirements in terms of reliability, in terms of throughput, in terms of latency that the auto OEMs are requiring from our networks. So we are extensively testing at M-City, but in addition to M-City, which is a test track, we are also testing at living labs. Example of a living lab we have at Lake Nona, which we announced last year in Florida, which is a residential community where we are doing the autonomous shuttle testing over our 5G and MEC, which is deployed in Miami and Atlanta nearby. And then there is definitely testing on the real roads, which is going to start soon with the auto OEM partners, already happening in some parts. But I think I'm really proud of our public-private partnership at Contra Costa Transportation Authority, where we have a US DOT grant, and we are deploying this technology on I-680 corridor, very near where all of you are. So a lot of exciting stuff happening on the real roads coming very soon near you.
Very interesting.
Yeah, that's awesome to hear about all of that research at all of the different locations that you talked about, Jyoti. So why don't we shift gears and take a look at what we've been doing with AWS Wavelength Zones. And Savi's going to go ahead and talk to us a little bit about it. So what is wavelength and how does it relate to telecoms like Verizon and 5G?
Sure, Dean. So before I go into what AWS Wavelength is, I want to mention, Jyoti is talking about the C-V2X use cases that can be enabled with the 5G and mobile edge computing. And if you look at it, applications are at the core of the innovation, and giving access to cloud resources increases the speed of application development and delivery. In that context, AWS brings Cloud Continuum, bringing AWS Cloud to where our customers want it, whether it is for on-prem with AWS Outposts to metro areas where large populations can be served with local zones, or the edge of the 5G network with AWS Wavelength Zones. So AWS Wavelength is essentially an AWS infrastructure offering that's optimized for mobile edge computing applications. AWS Wavelength brings AWS services to the edge of the 5G network, minimizing the latency to connect to the applications from a 5G device.
Yeah, it's really awesome concept, this cloud continuum, right? It's really like a continuum nowadays. So very interesting. So Just to summarize and to simplify it, AWS Wavelength is AWS Cloud at the mobile edge. Can you tell us what are some of the benefits of it?
Absolutely. It's AWS infrastructure, so our own compute, storage, network, top-of-rack switches, servers, disk, and the infrastructure that's embedded within our CSP or telco carriers, partners, data centers at the edge of the 5G network. So mobile application traffic now can reach the endpoints in the wavelength zone without having to traverse the internet. And as we know, when application traffic goes over the internet, depending on how many hops it takes on the internet, the latency could be from tens of milliseconds to a couple of hundreds of milliseconds. And this sort of latency might not be conducive for C-V2X use cases, especially like the road safety use case, hazard detection, teleoperation, etc. So by keeping the application traffic within the mobile network, since the network path traversed is shorter from the mobile device through the CSP's packet core and then hit the endpoint in the region, and with having a highly controlled QoS and routing in the underlying mobile network, we are able to provide low latency that's predictable and has less jitter, which is important for applications, especially the C-V2X.
Yeah, it's absolutely critical in some of the automotive use cases that we've been talking about. But one question that always comes up, as you know, Savi, when it comes to AWS services and their availability, is whenever we bring out a new region, for example. But now we're talking about wavelength zones. How do these relate to the regions and what's available?
Sure. So when we're talking about deploying applications in the wavelength zones, we can use the core services that are supported locally in the wavelength zones, like EC2 instances, EBS. We have extended VPC. And then for those applications that are based on microservice architecture and running in containers, we have managed service like Amazon EKS and Amazon ECS that could be used. And these services are supported locally in the wavelength zone. And also, these wavelength zones are essentially AWS infrastructure at the edge of the mobile network. However, they are tethered to the parent region via the high bandwidth link, which allows the applications to seamlessly connect to the rest of the 200 plus services like database, S3, Amazon SageMaker in the AWS region. Now you can deploy your applications and components of your applications that are latency sensitive in the wavelength zone, and then have the rest of the non-latency critical components running in the wavelength zone in the region and have them seamlessly connected. And not only that, since it's AWS infrastructure, it's the same programming interface like well-known AWS APIs, CLI, toolkits like CloudTrail, CloudWatch, and CloudFormation that you are used to for managing and monitoring your resources and delivering your resources in the region. You can continue to use them in the wavelength zones as well.
It's really powerful to think of all that you can do when you think of that super low latency from the vehicle to the wavelength zone. The next thing that people are asking, and everybody's kind of playing around with it hesitantly, is how much can we do from, say, an ADAS or an autonomous function as far as offloading perception, especially when you consider the speed and frequency with which you need to do that, and can you do that safely? So I don't think we know the answer to all of that yet, to have those important functions offloaded, but I think we see a path to some experimentation and some things coming down the road in the future. So Savi, can you talk a little bit about what kind of offerings we have or capabilities we have when it comes to doing things like perception in the wavelength zone?
Absolutely. You talked about doing perception in the wavelength zones, and perception offload is certainly one of the use cases that we see trialed with wavelength zones. If you look at connected vehicles, all the data that's generated from the sensors, the cameras, the LiDARs, the radar on the vehicle, we're talking about enormous amount of data, and all of this data needs to be processed, which would require either complex CPU and GPU processing on the board. However, with AWS wavelength zones and 5G, the high bandwidth and ultra low latency 5G connectivity, now you can offload some of this processing to the edge. with video recognition, image processing, and AI ML-based inference running at the edge, you can implement video look-ahead use case that can detect stranded vehicles or stranded people on the road, or detect any hazardous road conditions and alert the vehicle about any impending dangers, so the vehicle can now take the necessary action. And when we're talking about connected cars on the road, every millisecond latency matters when it comes to blind spot detection, lane change warning, and other road safety use cases. And also another use case that I can think of is distracted driver. This is one that that can be enabled with 5G and mobile edge computing with wavelength zones. Whether the driver is distracted, looking down, or not seeing people crossing at the cross sign or an incoming car at the intersection, having the ability to send the video and the images from the camera sensors and process it in real time and alerting the driver, the distracted driver, is really crucial. And this requires ultra low latency processing that needs to happen close to the vehicle. Another use case is teleoperations. Jyoti, you recently did some activities around this, right?
Yes, Avi, we are very excited about the use case teleoperations that we demonstrated with our ISV partners, where you can offload the massive amount of video from the vehicle and remotely control, when the conditions are right, you can remotely control the vehicle over 5G and MEC, providing that low latency connectivity. And also that QoS, or essentially a network on demand with network slicing, will be able to ensure for the duration of the time that a vehicle needs all these high KPIs like ultra low latency, high uplink throughput, low jitter, high reliability, that we are able to provide a slice of our network on demand, which is going to be key for such applications like teleoperations. And we are, as we speak, we are demonstrating on real commercial networks and environments at our headquarters, the teleoperation scenario. So I'm really excited about this use case.
Yeah, honestly, it's really mind blowing. And I think this combination of low latency, high bandwidth, it's really the killer app of the infrastructure, let's say. So, and it's awesome. Think about the difference between just operating, observing something, or controlling a vehicle remotely. That really requires that. That's the step, the innovation step that we can see here. It's really awesome. And Jyoti, just from Verizon perspective, can you summarize what's the advantage of having a wavelength area at the edge of the network?
Yes, Stefano. I think it's a pretty exciting time for us that we've commercially together, AWS and Verizon, have launched 10 metro cities in the past year. And we've been first to the market to bring that technology to the entire V2X ecosystem or the automotive ecosystem. If you look at the value chain, one company cannot deliver end-to-end solutions across the value chain. So I think our partnership between AWS and Verizon has really unlocked some really cool automotive applications like teleoperations. So MEC is going to be a key technical enabler for the automotive enterprise customers. What 4G did for consumers, we see that 5G is going to do for enterprises and many verticals, and automotive is going to be at the top of the list for us. And MEC is enabling them to deliver those solutions.
That's awesome. When we think of all of this that's taking place at the edge with the vehicles and all the different factors around safety and security, when it comes to C-V2X, there's been a lot of discussions around security concerns and validating that messages that are being sent, from the vehicles are coming from trusted sources and the messages could be trusted. So security is always our top priority at AWS. And I know that Verizon has a similar culture. What's your take on that?
Dean, go ahead, Savi. Yeah, go ahead.
Yeah, I was going to say, as Dean said, security is always our top priority. And AWS uses the same secure hardware and software for building and operating the wavelength zones. And it's a shared responsibility with the customer, with AWS providing the toolkit, the best practices, the guidance, and that customers can leverage while building and delivering their applications from Wavelength Zones. And especially in the context of C-V2X, when we are talking about constant transmission of safety messages between vehicles or vehicles and roadside infrastructure, they need to be authenticated so malicious entities do not take control or do not transmit invalid or incorrect information. In fact, we are trialing authentication as a service on how you can have secure information sharing from vehicle to vehicle, V2V, or the V2I, the vehicle to the transportation infrastructure, or V2X for that matter, using Wavelength Zones and Verizon 5G. Jyoti, would you like to add anything else to it?
Sure, thanks, Savi. And when we think about security, that's table stakes for us. Just like AWS, it's in our DNA and it's not an afterthought. So, and specifically for automotive, security is even more essential that we are able to in a timely fashion, detect any misbehaviors in that V2V ecosystem. And we are making sure that every message is authenticated, every message is encrypted and authorized before we trust that message. So it's a zero trust policy, and we rely on that framework for automotive as well.
Well, thanks, Jyoti. We could, again, as I mentioned earlier, we could probably continue this for quite some time. But, at this point in our show, we go to our In the Shop segment where we roll up our sleeves a bit, dive into the nuts and bolts of the topic, go a little deeper. So, Stefano, why don't you pop the hood and get us started?
So we already discussed about very interesting use cases like securing communication between vehicles to infrastructure, vehicle to vehicle, road safety use cases like collision warning, hazard detection, that 5G and edge computing can unlock for the automotive. So Jyoti, Savi, do you want to bring us into the shop and explain how that all happens?
Yeah, sure, Stefano. Let's play the video and walk through it. So we've looked at several day 1.5 safety use cases over 5G MEC. This is not just animation or PowerPoint slides. This is something we've demonstrated with 5G commercial network as well as MEC AWS wavelength deployments commercially, where the vehicles that have cameras, sensors, radars, lidars on board are able to communicate with the other vehicles. So how many times have you seen somebody jumping the red light or not stopping at the stop sign? We're able to alert the other vehicles on the road about such hazardous conditions and really prevent accidents. So the vision is vision zero. Zero fatalities, zero accidents, and zero emissions. So that's our vision for a safer future, and 5G and MEC are going to enable that future.
Savi, do you have other cases you want to talk about?
Yes, absolutely. Again, these are all really fascinating use cases. Let's look at how our customers can realize these using AWS Wavelength and other AWS services in the region. When it comes to connected cars, C-V2X is an increasingly important platform, and every single millisecond latency matters. With large number of sensors, cameras, lidars, radars, and each generating an enormous amount of data, capturing images, videos, you cannot realistically backhaul all of the data that's generated on the vehicle to the cloud. And for these reasons, such as data transportation cost, the reliable bandwidth availability on the internet, and also the time it takes to have this information transmitted over the internet to the cloud. But with wavelength zones, by virtue of being located at the edge of the mobile network, now you can run board safety message processing, video recognition, inference using the CPU and the GPU instance types that are available in the wavelength zones. And you also have the option of sending the data over the high bandwidth. Like I said, the wavelength zones are sitting at the edge of the mobile network. However, they are also tethered to the parent region with this high bandwidth link. And now you can send the data, the images, video, and telemetry data back to the cloud and create a data lake for further analytics and data management.
That's really, some great points you mentioned, Savi, especially when you think about, as ADAS and we get to like L3 kind of deployments, we need to be able to kind of capture snapshots of events. So, particular events happen in the vehicle where we've got some low confidence performance of the perception or the path planning functions. We want to grab a snapshot of the raw data and send that. And using the 5G connection, we can do that at very low latency and high bandwidth very quickly from the vehicle, and then pre-process it, using the GPU and CPU combinations that you talked about at the wavelength zone before it gets passed on to the data lake, as you talked about. But so that's really interesting. But also you've got, Jody, you were talking about inference at the network edge. Why don't you talk a little more about that and some of the benefits for automotive?
Yeah, sure, Dean. I think getting the data from the vehicles is key. Getting the relevant data is even more important. And getting that relevant data to the mobile edge computer MEC, where we can do some inferencing, quick inferencing, and send that information back to the other vehicles that are in the vicinity. If I'm driving in New Jersey, I really don't care what's happening in Miami. It's within that wavelength zone, in the local context, what's happening. I really care about that. And I think that's inference will help the other drivers. So when we drive, let's say I get into an accident, it's only I will learn from that. But here, all the vehicles are sharing that data. It's important for the vehicles to share that data and adjust accordingly so that we can avoid those accidents. And I was surprised at reading in the news yesterday that during the pandemic, the number of accidents grew, even though we were not traveling as much. We were not on the roads, but there is this huge need for safety on the roads. And really the goal is to reduce those accidents and in quick decisions that need to be made at the edge, and the users need to be informed of the changing traffic conditions. I think MEC is going to enable that very drastically and at scale. I think that's key, that we are able to do it at scale.
Yeah, that's really use case zero. So important use case to increase safety. Absolutely relevant. And Savi, how does that happen into the wavelength zone? So can we dive a little bit deeper on that?
Oh, absolutely. Let's look into how inference at edge can be implemented seamlessly with AWS Wavelength Service. So to get started, when we're talking about application deployment in the wavelength zones, customers can create a VPC and a subnet in the wavelength zone, bring up the instances. However, if they already have a VPC running in the region, they can now extend the VPC to the wavelength zone. And you can create subnets in your VPC in the region and in the wavelength zone. This is essential, especially for use cases like inference at the edge, where you want to run certain components in the wavelength zone, in the subnet in wavelength zone, as well as in the region. And now let's dive into how you can run AI ML based model in the region and do the inference at the wavelength zone. But before I go there, I want to touch on a construct that we created for AWS Wavelength called Carrier Gateway. And this is really important because Carrier Gateway is the one that gives you that external connectivity out to the internet and out to the mobile network, to the users' 5G, the equipment that's connected on the mobile network. And also associated with this is the network border group. Essentially, this is a list of publicly routable IP addresses that is reserved, allocated for that particular wavelength zone from from a particular carrier. And you can pick an IP address from this network border group and assign it to your EC2 instance. So now that becomes reachable from the mobile network. Now coming to the inference at the edge, when you are looking to run AI ML model, we recommend running the AI ML model itself in the region. And we do have a support for major frameworks like TensorFlow, MXNet, and PyTorch. However, if you don't want to do the heavy lifting of the complexity associated with machine learning, then we do have AWS managed service Amazon SageMaker that you can use to build your AI ML model in the region fine-tune it, refine it using the data set, and then decouple the inference engine from it and run the inference engine, the inference endpoint manually in the AWS Wavelength Zone. So, by the way, in the Wavelength Zone, we do support G4DN 2 extra large, the GPU server type, which you can use to run the inference. So this way, you can retain and refine the model in the region. And when you need to update the model, you just need to update it in the region and not have to push it and run the updates on every vehicle in the fleet. So having the option or having the ability to run inference at the edge literally gives you that option of refining your model on the go in the region and pushing out only the inference engine to the MEC.
Wow. Well, thanks, Savi, for that. That's a great explanation of all the benefits of what we can do with Verizon and AWS Wavelength. Thanks to you, Jyoti, as well for joining us today. It's really been a pleasure collaborating with you both on behalf of our customers.
Yeah, it's really been great talking with you. I learned a lot of things and how we can better give intelligence to cars and vehicles at the edge. That's really so cool. And low latency, high bandwidth, a lot of things. So thank you very much, Jyoti and Savi. Really a great session.
Thank you, Dean and Stefano. It was my pleasure to be here on this show, and we're just getting started. So we can't wait to see what future holds for automotive industry, and we're going to transform it together.
Awesome.
Same here. Thank you, Dean and Stefano. It was a pleasure being on the show. And I hope the viewers are able to take away the benefits of 5G and edge computing with AWS Wavelength Zones. And this spurs new innovative use cases across the automotive industry.
Oh, fantastic. So after hearing about all this interesting content from Jyoti and Savi, let's take a look at what's around the corner, Stefano.
Dean, a second episode is almost over. Can you believe that? So much interesting things to talk, so many, absolutely, it's not enough time. By the way, in case you missed the first episode, you can watch it on Twitch, YouTube, and using the links in the chat. And Dean, what are the events coming in the next weeks?
Yeah, so we mentioned on our last show, Nisarg Modi and I have a session at the SAA World Congress Experience coming up on April 13th and 15th. I'll talk about connected vehicles and data, and Nisarg will be talking about EVs.
Yeah, I remember your talk title, the one I opted for the Holy Grail, right? So, and given today's episode, by the way, I even more convinced about my choice. So, and we still have, we still have NVIDIA GTC coming up mid-April. So, and our Wavelength team will be there in force with 3 sessions touching some of the use cases we discussed today.
Yeah, Savi actually has a session where she's going to talk about extended reality streaming from 5G MEC using Wavelength and NVIDIA's Cloud XR SDK. And on a similar topic, Saravanan, another AWS colleague of ours on the Wavelength team, he's going to talk about accelerating VR adoption using 5G Edge. And then lastly, a really important topic for the industry, Sebastian is going to be talking about securing the integrity of the C-V2X messages using mobile edge compute. And that's going to be with Harsh Patil from LG. We talked a little bit about that in our session earlier. So that's going to be great.
Yeah, very interesting talk. I can't wait to see that. And nice to see, by the way, virtual reality applications at the edge. Recently read about some interesting cases about VR application vehicles, maybe a topic for the next episode. But do not forget the other sessions we mentioned during last episode with Vijita, talking about how the cloud can be used to accelerate AV development, and Francesco, who will talk about what Renault is doing with high definition rendering on 4,000 GPUs, and links here in the chat.
Yeah, well, hopefully our chat moderator is able to address the questions from the chat room and then we've also shared a number of interesting resources on 5G, MEC, and Wavelength. So hopefully that you guys got enough info.
Yeah, but if you're catching this on demand, just send along comments or questions to media series livestreams at amazon.com or use the hashtag allthingsautomotive.
And the show doesn't end here with Verizon. In 2 weeks, we'll be back with Shravanti from Toyota Connected to talk about connected vehicles. And if you recall, we focused our very first episode on the vehicle software architecture, the vehicle edge with BlackBerry Ivy, the edge in the car. And then next episode, we're going to be talking about how we're ingesting and intelligently processing that data captured from the massive Toyota fleet and using a collection of AWS services in the cloud.
Yeah, and our colleague Sandeep from AWS will be there too to give us details about the architecture that Toyota put in place for its connected vehicle. And yes, Dean, definitely. Last time I spoke with Sandeep immediately after reInvent, I congratulated them about the huge, really huge frequency of data the system is able to manage. So I really can't wait to hear more about that.
Yeah, it's going to be awesome. So we're really excited about that. And it basically wraps up our show for today. So thanks for joining our second episode of All Things Automotive. And we hope to see you back next time.
Thank you so much for joining us, and see you next time on All Things Automotive.